Be here. So my role is as District Veterinarian with local land services on the northern Tablelands. So I'm based in Glen Innes. So my day-to-day role is herd and flock health problems, along with some of the legislative stuff with regard to zoonoses and biosecurity in general, and emergency animal disease. But up here, where we have one of the highest concentrations of livestock in the state, New South Wales, one of our big problems, we get a lot of resistance to parasites, to drugs. So I'm constantly investigating disease outbreaks, doing post-mortems, and I do some worm egg counts, etc. So in this area, off the edge of the northern Tablelands, the main problems that we get are roundworms and liver fluke. So the liver fluke are obviously a zoonosis, and I think it's fair to say that Glen Innes is well known in parasitic circles because we had a nasty outbreak years before I got here in people where they got infected, and it was really, it proved typically difficult to identify in people because they weren't expecting it. We have roundworm problems in our animals, but they're generally not ones that spread across to people because I'm dealing with livestock. The ones that spread across to people are more often the dogs and cats, so the Toxocura type, and also hookworms. We tend not to see those very much, although I do a few investigations for individual producers just to show that they need to worm their animals. We do run into tapeworm issues. So we have Hydad, which is a typical zoonotic problem of probably underestimated importance in some parts of the world. We also run into some of the tapeworm problems further on down the track where sheep and cattle get some of those teeny cysts in the tissue that are picked up at meat inspection. We use chemical treatments of various sorts. I did mention that we get drench resistance because a lot of farmers over the years have routinely used the same drenches all the time. Means that the worms that survive are resistant to those drenches or develop resistance to those drenches. So that's a real problem, and especially when it comes to the zoonotic ones, like let's say the liver fluke, because we are getting liver fluke that are resistant. The life cycle is really complicated, not really complicated, that's wrong. It's not a straightforward one. They have intermediate hosts. So we have, as well as using chemicals, what we try and advise producers is to develop management protocols which take into account such things as the length of time the eggs take to hatch, the life cycle of the whole parasite, where intermediate hosts live. So it becomes a fascinating epidemiological challenge, A, to work out that in some cases, B, to get producers who think that the answer is a drug, and if we just dose them at set times, we don't have a problem. So those are the major aspects of what we're looking at.
You mentioned some life cycles, some of which are complex and involve intermediary hosts. Could you outline a few examples of those?
Yes, I suppose the liver fluke is a classic, that the adult could be in cattle or sheep, but it could also be in deer or kangaroos, both of which we have a lot up here. So that fluke then lays its eggs onto the ground. The next stage of the life cycle is in a water snail, and there's several different species. Some are native Australian, some have been introduced. So these eggs then hatch in water, and the little creature that comes out of the egg then swims around until it finds a snail. Then it penetrates into the snail. where it develops into another phase of what we call a redia, which multiplies it by some 500 times. So then we've got little cercaria that come out of those, and they're like little tadpoles that swim through the water until they land on plant material, still in the water. And then that water subsides, and the metacercaria or the cercaria form little cysts, metacercaria, on the grass or whatever's there. And then along comes the animal and eats that. So they become infected and that hatches out. Now, the human aspect of it is very commonly either people drinking the water, which can happen, but the Glen Innes outbreak, and the ones I've seen elsewhere in the world, are where they eat plant material. And around here, it's been watercress, which is in there. The water trickles on over it. So people come along, harvest the watercress, sluice it off with a bit of tap water maybe, but the cysts are still stuck to the pasture and to the watercress plant. So that then infects them. And then when that little larvae sort of hatches out from what they've eaten, it migrates through the body on the way to the liver. So you then get damage of the tissue, which could be in the liver, but it can be elsewhere in the body. And depending on where they are, then you get a set of signs, which, as I say, mostly in our livestock, they're liver-based, but it damages the blood and so forth. So there's a whole raft of different signs that we might see.
Wow. You mentioned Hydadids, and Hydadids has a complex life cycle as well. Could you explain that one?
Yep. So the hydatid is the cyst of a very small tapeworm. So you got your big ones that are like tenias that are several meters long. The little echinococcus is minute. It's only got a few segments there, but the head is attached. The bottom segment drops off, and then out they're hermaphrodites, so there's no sort of copulation between males and females, so the egg segments drop out and come out in the feces. Now the main host is most commonly a canid, a dog, a fox, wild dog, whatever. Those eggs come out in these little segments, which usually break down in the latter part of the intestine, so that the feces is then full of little eggs in there. But these eggs form cysts. And so when the feces is dropped on the ground, the feces disintegrates in the rain, the cysts survive. So then along comes another animal, eats those cysts, and they develop in that animal into a fluid-filled sac that's got the head of the tapeworm to be in it, and then it's covered with fluid. So if you're, let's say, a sheep, then you get a cyst, yay sort of size, but it's there. But if then a dog comes and eats the dead sheep or is tossed the leftovers from slaughter, it will develop the cycle again. But if, for instance, it's a human, then that cyst doesn't stop at that size. It gets bigger and bigger and bigger, and it can develop in all sorts of parts of the body. So a common spot are where there's capillary beds. So like the lungs or the liver, they could be in the brain. There's x-rays out there of people that have got a massive cyst, but those cysts just keep growing and growing. So there's a chap in Glen Innes who still claims that he had the biggest one ever removed in Australia. And I've seen the scar, and it's open from stem to stern, just below the ribs. And they have to make a big hole, because if you rupture that during removal, then the medicos tell me that's a big problem, because you then get lots of little heads spreading around the abdomen. So it's a really integral one. But the interesting thing is that with those droppings, we had big problems down on Monero years ago, where while people were going into the parks, having their sarnies and their pie and tossing and leftovers, leaving their Barbie bits and pieces, wild dogs would come in and eat all these scraps, leave their feces around the campsite. So in a few weeks' time, when the next visitors come, they're collecting a bit of wood for a campfire or generally playing. They get these eggs onto their fingers, they don't wash their hands, they lick it and blow me down, they get infected that way. So it was a major developing zoonotic problem down there. I had a friend, still a friend fortunately, and he was a big lad, and he got what he thought was going to be, what his doctor told him were growths on his liver, cancer, and he faded in front of us. But my wife, who is a theatre nurse, said, no, that's not cancer. I can smell cancer. And he said, go back to the doctor. Anyway, they tested him, found that it wasn't. It was half-healed hydatid cysts in his liver. And the moment he knew that, his weight came back on again. And that's 20 years ago.
Wow, what an incredible story.
Yeah, happy ending.
Oh, that's fantastic. So they're two quite complex and different life cycles. Is there another example you could share of a different life cycle of a parasitic worm?
So the straightforward roundworm, our hookworm, so could be ankylostomum. So that really just the adult lays its eggs in the, let's say a dog or a cat, comes out the back end, and then the little larvae are in the ground, especially in muddy, wet conditions. Along come people, especially little kids, no shoes and socks on. The hookworm larvae penetrate the skin and get into the body that way. So just like so many of these diseases, youngsters don't have a strong immunity, so they're likely to get it. There's also Toxocura, which is a common parasite of dog, very, very common. So again, kids not washing their hands, get the eggs straight out the backside of the dog or off the ground. And those ones can migrate through, excuse me, through the eye. So you can get either lesions on the white of the eye, or if you use one of those ophthalmic gadgets to look in the back, you can see the damage to the retina. And again, some people are much more seriously harmed by that, I'm told, than others.
Okay, so how can people protect themselves? You mentioned washing your hands, wearing shoes in certain areas. Are there other ways people can protect themselves?
Suppose one of the classic things, if we go back to the veterinary side of things, it's that meat hygiene control in the slaughterhouses. So that if your people are in the countryside and doing a home kill, that's a potential source. I mean, I have to say, you've got to know the life cycle. When I was a student, we were in Liverpool in the UK, and we went to a butcher who was notorious for having liver fluke livers that had liver fluke in. And to be honest, I mean, it's a good many years ago now, we'd buy that liver, eat the good stuff, and take it back on Monday and say, look what we found in our liver, we need some more, because we knew we couldn't get infected from the adult liver fluke. We could only get if it had gone through the life cycle. So it supplemented our student budget. You know, we were all, well, there were 3 vets and one other in the digs. But so it's a question from our point of view of knowing the life cycle. When it comes to things like dogs and cats, it's a question, I believe, of using routine treatment, which is much more important if you've got young children or people with disease, you know, radiotherapy or what have you, so that you're treating them more often. I don't like overdoing chemicals because we get side effects, we get resistance developing. So it's really a question of balancing that, but it is hygiene, it's breaking that life cycle. And so from a livestock point of view, we recommend having people that rotate their animals through paddocks, breaking the paddocks so that larvae that hatch out, for instance, will die off because there's no host around there.
Terrific. And Nigel, what information would a doctor need from a patient to work out if they're being impacted by those different kinds of worms? What questions would they ask, or what would they need to know?
I think the dietary habits of people and the lifestyle habits would be important. It's not always possible to use lab tests to diagnose these things. It does take time to get the relevant parts of the history out, but because I think a lot of these contaminations can happen in places that people don't think about it. I mean, they don't think about handling bits of wood or even the seat where they've been down in the national park. I was down there a couple of days ago looking at some horses, and there were campsites there. And you could bet pound to a penny, because we actually saw a wild dog down in the park. That one had just been around the campsite. So it had almost certainly been contaminating the environment. It had certainly had no treatment. So it's contaminated. So people wouldn't know because they can't see it.
Oh, thank you very much, Nigel. That's a really great insight into some of the common parasites in your area, and also wider spread through Australia, and a really great look at some quite different life cycles and modes of infection that you've given there. Thank you very much for your time.
No, my pleasure. More than happy. If anybody's got any questions from a vet's perspective, more than happy to help them out.